Let me start recording. So the first presenter is actually Juan Cuellar.
Hello, it's me.
Yeah, hi. He's going to talk about taxonomy and future direction of sustainable cloud computing. The first part actually, because it's a long paper, so we divide it into two different groups. So you can share your screen and go ahead.
It was tricky for me, at least.
The paper?
Yeah, because it explains a lot of things, but like I think that it's only like a little thing that well, it doesn't go it doesn't dive into the topic. You know,
Okay.
it only mention the things. Yeah, but that's my opinion.
Let's see how you want to talk about it. Yeah, you can share your screen.
Okay. Hello, everyone. You already know me. My name is Juan. And for today, I will present a very interesting paper. It's related to sustainability. It's actually a topic that it's really appealing to me. Also is linked with cloud computing. So I will share my screen now. Hold on. So you can see it, right?
Yes, we can see it's just not in presenter mode.
Okay. Well, the name of the paper is A Taxonomy and Future Directions for Sustainable Cloud Computing. It's a 360-degree view. This is actually a really long paper. Another classmate is sharing the other half of it. So, well, let's start. For this presentation, I developed it in introduction, objectives, and I will start develop all the topics that is actually included on it. As I said before, is linked with sustainability. So we are going to speak about how cloud computing can be sustainable using mainly different configurations about how to make CDCs sustainable. Okay, so let's start with the introduction. Well, first of all, cloud computing offers a variety of applications, as we already know.
Juan, actually, you're just seeing the main page, so you have to put it in presenter mode.
Oh my God! Wait up.
You're just seeing the actual page.
You mean it's not changing?
No.
Okay, maybe hold on.
I think you can share the screen, not just the application.
I shared the screen already. Is changing now or not yet?
No.
What's going on with this?
You're using two monitors?
No.
So if you share the whole screen, probably.
Okay, I think I know which is the problem already. Okay.
Yeah, all good.
So now it's changing, right?
Yeah, all good.
Okay, sorry about that. Okay, so let's start with the introduction. As I said before, cloud computing offers a variety of applications. As we already know, there's a lot of data that needs to be stored and managed. So for the future, it's really imperative that cloud systems can be energy efficient, because since the cost will increase if the data centers are not sustainable enough. We must be aware that with the recent growth of Internet of Things, the applications that are based in cloud are growing exponentially. So if there is a large number of cloud data centers, the carbon footprints will increase and will affect the sustainability of the cloud services. We already know about this, but I must explain, or I prefer to explain, what is a cloud data center. It's basically a place where information is stored and it's distributed in a distributed way, and could be a physical server in their own company, or a company can hire a service from a third-party supplier. Now, let's check some hard data. So each year, the electricity consumption in CDCs is increasing from 20% to 25%. 78.7 million metric tons of CO2 are produced in data centers, which is actually really bad for the environment. And in 2030, the energy consumption in CDCs could be 18,000 terawatt per hour. So it is too much. The cloud providers like Amazon, Google, and the biggest companies that we already know make an extensive use of cloud data centers. In order to do this efficiently, well, the companies must invest a lot of money and a lot of energy storing each bit of data. So the challenge is actually design sustainable CDCs. Now, in order to tackle this challenge, several researchers have already proposed many management policies, different algorithms, and different architectures. But the energy efficiency is still a really big challenge. The first thing that service cloud providers can do is change the energy that they are using. For example, they can start using renewable energy or green energy as we know it, instead of the traditional fossil fuels. This actually can help a little bit, not a little bit, can help a lot to tackle this problem. So this is some data that is important to know, and why it's important to design sustainable CDCs. Now, the objectives actually of this paper. This paper review comprehensive taxonomies and systematic review of existing techniques for sustainable cloud computing. Now, why in the title we saw the word taxonomy. So why taxonomy is relevant in this paper? Well, taxonomy is the practice and science of categorization and classification. Could be by hierarchy, groups, or types. Actually, in this paper, it shows different types of CDCs with an organization in how are being sustainable. Some are from capacity, another ones are focused on electricity or energy, it's more accurate, and or virtualization. There is, the paper describes in certain order each taxonomy. And well, how organize sustainable cloud computing. Okay. So this organization can be application design, sustainability metrics, capacity planning, energy management, virtualization, thermal aware scheduling, cooling management, waste heat utilization. This is how the paper organized all these taxonomies. And also it's relevant to know that since exist different sustainable structures, it is important that these are classified. And the systematic review comes in how all the taxonomies are presented and described. Okay, now for the topic development. Well, first of all, we must check how CDCs can be sustainable. Could be powered by renewable energy, as I said before. Green energy replaces traditional fossil fuels. Employs energy efficiency mechanisms. These actually reduce carbon footprints in great extent. And also uses waste heat from service. This means the heat that is already dissipated from the current service working in the CDCs can be reused again, and uses as well free cooling mechanisms. All these factors contribute to reducing carbon footprints, operational cost, and energy consumptions. It is important to know as well that we need to measure the CDCs, and this sustainability metrics helps to achieve this objective. It is important to monitor and measure the performance, the taxonomy of the metrics that has been, that actually these metrics has been done on core operations of the CDCs. So in order to have an effective resource management, we require flexibility. And with these metrics, it's possible to get control of the CDC and implement what is needed when we require it in order to improve efficiency, save energy, and of course, we must have performance metrics to know if it's actually working for our customers. Well, the first taxonomy that we are going to explain is application design. This is a taxonomy where that is focused on the applications that are actually running in the CDC. So the first part is quality of the servant, quality of the service. So different applications have different requirements. For example, evaluation cost is the total money that can be spent in 1 hour to execute an application successfully. The execution time is the amount of time required to execute an application successfully. Energy is the amount of electricity that is needed to execute the application successfully. And security is the ability of the computing system to protect the systems from any attack from a hacker or something. And the throughput is actually the number of tasks that an application can execute. Now, the next one is the application models. Task-based is actually the large task is divided into small tasks in order to be performed. The MapReduce split the dataset into chunks for better execution. Backup task or parameter sweep task is actually several workloads made in parallel. Stream processing is small size data generated by thousands of sources. Message passing provides communication functionality between a set of processes. Graph processing analyzes, stores, and processes graphs to produce effective outputs. Now, in the workload type is actually the workload management in sustainable cloud computing. The batch style workload is actually the job or the task that is being required is queued and executed when the resources is available. This means the task going to the line, and when it's the turn of that task, it will be accomplished. And for immediate response, critical interactive is for immediate response. Some tasks needed to be done before a deadline, so the resources are focused on that specific task. And architecture of the application is how the tasks are managed. Could be centralized or decentralized. In centralized, there is a main controller or central controller that manage everything, and all the workloads are bonded and share resources. Decentralized is actually the opposite, are not bonded, and each task performs individually. The next one that we're going to talk about, the next taxonomy, is capacity planning. It can be done for power, infrastructure, IT devices, and cooling. And actually, this must be planned effectively considering the devices of the end users. Effective capacity planning can truly enable a sustainable cloud environment. So the first part of the capacity planning taxonomy is component. It is actually divided in 3 main groups. Component. So is sorry, the components are required for everything on the CDC. And IT workload is composed by 2 groups, and similar to the thing that similar to the previous taxonomy, it must be queued and as well attended immediately. Application models, this is how the capacity is modeled, and could be based on QoS requirements or configuration based. And this is on the configuration. This is how it responds to the configuration of the CDC. And autoscaling is how the planning reacts to the workload. Could be reactive and could be proactive. The reactive part acts on feedback methods in order to perform the task, and proactive uses predictions in order to fulfill all the tasks. And utility functions are defined to measure the aspects of capacity planning. Cost is the amount of money that can be spent to design a CDC, and the latency is the amount of execution delay with a particular configuration of the CDC. And the next taxonomy is energy management. This one, I think, is really complicated, or at least is the one that I noticed it that is kind of extensive, as well, a little bit hard to explain. And for me, particularly, it's really important since the main problems or the biggest numbers in carbon footprints and electricity, well, comes from this. Okay, so just wait up because I'm supporting myself with some notes. Okay, for energy management, there could be some two ways to tackle two main like root three. How do I call it? Well, two main lines to tackle: static and dynamic. The first one, static, refers basically to, it's more engineering oriented. Could be if the scope, it's a big scope of optimization of energy consumption, because computing components of the CPU consumes 35 to 40% of energy. And the optimization of energy at CPU level can be performed at the instruction set level or register level. And other components of the system, besides the CPU that consume large amounts of energy, are software systems, network systems, memory components. So energy consumption can be reduced by proper distribution of resources geographically. So this means that if we distribute properly all our physical devices, we can also have some energy saving. And as well, the selection of a suitable network topologies with good compatibility. Well, for dynamic, the dynamic way, there is a different dynamic power for each range. During low activity modes, a CPU consumes 30% of the peak value of its energy consumption and can be scaled up and down up to 70% in order to improve energy utilization. The number of components can be scaled up or down based on the range of dynamic power. So it is divided in three main lines. That is resource management, resource consolidation, configurable components. This one includes the CPU, which support low activity modes at the component level, and dynamic energy management can be used to control the CPU. The CPU is the main source of energy consumption. Energy may be saved by reducing the processor frequency through manipulation of supply voltage. For different devices, semiconductor chip vendors are optimizing the energy consumption. For resource consolidation, it's actually a technique for effective use of resources. This includes processors, memories, or network devices in order to minimize the number of all resources and locations of servers that a cloud company requires to serve user requests. Okay, and for resource management, it's actually a real challenge to address this, because we need to allocate the resources in an energy efficient manner for the execution of workloads. Also migrate workloads from one machine to another to save energy consumption. And the devices need to be switched off to save energy consumption without degradation. So in order to solve it, the resources are selected based on previous executions of the systems in terms of reliability, energy consumption, the workload that actually they can solve. And always there is a need of continuous monitoring of resources in order to have a good allocation of what we need when we need it. So In this way, monitoring the modules improves the productivity of reactive management. So this is kind of hard to explain. And this is all for my presentation. So do you have questions? I think you have.
Okay, thank you, Juan. Now I see why Paul was saying it was difficult. I see there's a lot of information, but a small part.
Yeah.
But anyway.
So yeah, as I mentioned, like I was trying to focus, especially in the questions about the high level topics, because yeah, they are describing right now, they are trying, how you say, to describe how like everything works, for example, right now. But they are not saying exactly, well, really detailed how everything is impacting, like for example, on performance, on energy, or things like that, that it's really difficult. Or also a lot about, they are not talking a lot about methodologies and what things they are doing in every single part. I think that that actually would be like a really big paper. But well, yeah.
Actually, well, there is something that I commented in Mari. If you read the paper, there are a lot of prefixes that they are mentioning. And I think in those prefixes, you can find all the information that you want.
I can barely understand because it's breaking.
Yeah.
Okay, can you hear me now?
Yeah, better.
Okay. What I am saying is that at the start of the class, I talked with Mari that in the paper you can read that there are a lot of mentions to some prefixes, but well, the prefixes are not in the lecture, so we cannot see. But for example, they say that they have found some challenges, but you cannot read about the challenges because they are in another prefix.
Yeah. Actually, there are so many, and they sometimes they have an array of prefixes. Like I saw that they have like between brackets, like this section, this section, this section, this section. So as I mentioned, like it was hard to read, at least for me. But either way, apart from that, like I think that I didn't hear it in the presentation, but one of the main topics that it's being discussed, at least on the first sections, is that about the power, right? And that, for example, to have sustainable cloud computing, the power is one of the important factors, at least that was my impression. And a lot of power consumption generates a lot of carbon emissions and also high costs, right?
Yeah.
So I don't know if anybody of you think that there is like a way that it was not described like in the paper, or that where we can achieve the reduction of the carbon and also cost reductions, but in short-term goals. I'm saying as short-term goals because sometimes it happens that when you start something, it's more expensive until it gets like in scale, right? So I don't know if anybody can think about like any action, well, way where companies can reduce the high carbon, well, reduce the carbon generation and costs at the same time.
Well,
yeah, I'm only wondering because I was thinking myself that.
Well, actually, as you said, anywhere in the paper it says something like that, like in detail how it's been done.
Yeah.
But the reduction of carbon footprint can be done easily, changing the fossil fuels to green energy. But I think at this moment, green energy is a little bit more expensive.
Yeah.
And so at the same, do it at the same time.
Because I was thinking exactly the same. Because I was like green energies or location, right? And for example, for achieving some of the demands that they want, like you have to increase a lot of management, or technologies, even when you can like reduce the costs of energy consumption and things like that. You can increase, like, for example, the pricing components, like it's like cars. When you pay more for better quality cars, a lot of times they last longer, but they are more expensive, right?
Yeah,
So
you can do it in
Actually-
volume, like doing a big investment in green energy, and then it could be now profitable, and also you are saving money. Like maybe, I don't know, $100 million in eolic energy, another part of those 100 in sunlight, and maybe in that way it actually, you can save money, but in long term.
yeah, I was thinking, yes, I agree with that.
One of the things that I find really interesting about this paper, and I didn't know about that, one of the rules that you need to follow for being sustainable is like use the heat that is generated by the servers,
Yeah,
by the
like
closed servers.
their usage, right?
Yeah, but for me it's interesting because I didn't know that you can be able to do that. But for now, I didn't find any like real application of the heat. Does someone know something like a use case of how you can use the heat that is generated by the servers?
I think, Pedro, it's regarding that you are mentioning. Some company, I don't know which, but in Finland and also Denmark and really cold countries, the company put the servers in the equivalent to a heating room, and the heat generated by the servers, it's also useful for the winters in that regions of the country. I think it was an experiment for Denmark and also Finland.
Yeah, that sounds good for those kind of countries, but I don't think that could be good in Mexico.
No, obviously not.
But the heat is regulated by the fans, isn't it? Inside the clusters, each platform or each CPU, the temperature of the physical machine is regulated by the fans.
So
You can set up the fans in whatever speed you want. I mean, the 100%, the 50%, and you can control that even if the country is so hot. I mean, maybe Sonora desert, or maybe here in Guadalajara that we have the cluster on Intel.
No, but I think that's the other part, right? Like the cooling rule. No, I mean that they are saying that you need to take advantage of the heat that is generated by your servers, so you can use that heat in other applications. I don't like the one that David said is good. I think that's a good idea, but I don't know in other countries where we don't have like these hard winters.
And also something that the paper mentions later, I don't remember if it's on this section before the 3.5 or later, but it says that for between 40 and 50% of the energy is used on the fan and cooling systems, right? So you are using a lot of energy only trying to cool down your system, right? And like all the energy that is not really well used, usually the waste of the energy transformation between, like, let's say, electricity to mechanic or whatever, it's always a result on heat, right? So if the system is not efficient enough, it will generate more heat, right? And also you have to pay for cooling the system, and you spend, like, even cooling the system, you are, how do you say, consuming more energy, and the providers that gives you that energy either way probably are causing also CO2 emissions. So it's like, even if you are not generating it, other thing is generating it like in a different way, right? Because somewhere you have to get like the energy. Like Maddie is putting something about the heat reuse.
As
Yeah,
Paul
but
mentioned,
I was just looking
another-
for information. It's just I saw some interesting links. It's I mean there apparently there are some efforts towards that trying to recycle or do something with the heat, but apparently it's not so efficient also. I mean what they were saying, they can convert it to asset in a certain part of the world, but it's not that easy, you know, to reuse that heat.
But it's really difficult, because if you overpass that amount of heat on a physical hardware machine, the system can crash. There's a
Yeah.
possibility that the CPU can crash, and I have seen that a lot of times. We have some tests about to test the silicon on that part from the heat, and I have seen so
Yeah.
many issues with that. So
Nobody has
it's hard.
Nobody has seen that when you are in the sun and your cell phone says like, it's turning off because of the because it's hot.
Yeah.
So yeah, things that start because of also the dilatation and things like that impacts a lot, right? On the performance, on the communication, on the how do you say ruido in English? On the
Noise.
noise, signal noise, you know, and things like that. But I have other two things that I was thinking a lot when, well, actually I thought like 10 things, but on the same paper, something that it was interested for me is like, for example, it mentions a lot the cloud data centers, but mainly for big companies, right? It doesn't like, it separates a lot the big companies versus the small companies, such as Facebook, Microsoft, IBM, and things like that. And they say like, they generate a ton of CO2, right? Of carbon emissions. That equals 2% of the global emissions. And right now, nowadays, like for example, in 2022, I'm wondering, like since we have like the SaaS services, like Amazon Web Services, like the cloud platform and things like that, how many of these cloud data centers are being used for internal use, and how much, what's the percentage of that is being used by clients, you know? So that's something that I question myself, because I'm like, okay, we're saying like, okay, it's increasing and we're generating, but actually probably it's much better if things are being used like in cloud data centers from big companies, rather than each individual having that, right? I think that there is like more waste of resources and more energy emissions and things like that if it's everything apart, right? So I don't know if anybody has like any opinion about this topic.
What do you mean by internal company? You mean like if
internal use?
But if you mean like Amazon uses more of their servers, or we use more of their servers, right?
Exactly. Yeah, like if they use more, there are more clients that are using their servers for their own benefits, rather than Amazon for their internal benefits of their own company.
Yeah, that is hard to say. What I do believe is that in any way, Amazon and Google are more aware of how much they are spending and how they should be sustainable, because they are the ones that are actually paying the bills, right? They are like really seeing the consequences.
Yes.
While on the client end, I mean, there is no transparent ways for you to see and go into their dashboard and say, hey, hello, you just like throw or cause another flood somewhere, right? Because that wouldn't sell like at all.
Yes. So, yeah, but so that's where I question myself, right? Like, for example, first of all, how much is actually from other users rather than them, you know? And who has more responsibility? Also the responsibility of this part, because that's one of the things that I was thinking about, because like, for example, there are so many techniques and areas that conforms the cloud computing concept that cannot be addressed. And why do I think that? It's because, for example, when they are providing some services, the clients are the ones that are managing all the data that it's being transferred between different cloud providers, between servers, how long the application is running, like ETL services, whatever. If they select an EC2 versus a Lambda, for example, how long it's going to run. But the providers are only saying like, okay, I can give you this, right? But at the end is the decision of the clients in how long it's going to run, So I don't know where is the line. Like, I don't know if the cloud provider services can set or define a line or a set of rules on how to do more, like to reduce the cost on this situation,
I think in the energy part, the paper said that most of the energy that is consumed is with devices that are just waiting, devices that are not computing actually. So, well, responsibility is sure, I will say, but I think at the end of the day, like Rodrigo said, who is paying for the energy is Google, is Amazon. So I think they are like more interested in reduce that energy, because at the end of the day, that's money, right? And and it's a business. They want to profit after doing all what they need to do. So yeah, at the end of the day, I think everyone has responsibility because we are living in the same world, but it is more the person who is more interested about this. I think at the end of the day, it's going to be the companies that are paying for this.
I mean, there probably already is somewhere out there some. I mean, we always have like this stuff about like infrastructure aware frameworks, right? I mean, these frameworks that do know where they are running and somehow manage to take decisions according to where they are. So maybe there is some proposal out there that we should search for that is like energy aware framework that basically all the way down to the application, we know how much we are consuming, right? And in that sense, it is easier for us, even from the software level all the way down, to start making smart environmental decisions. The thing is, again, these years and right now, since most of us, of the people that are using these services, don't see the consequences, I mean, there's no really something that can push you into using that stuff. And even worse, if it decreases availability or compromises reliability, then
and now I just remembered like about all these topics, like for example about the costs, about the energy, about taking advantage of the heat, about blah blah blah. Well, it's mentioned on the next points of the paper, but for example, it's about physical location, right? That for example, AWS, that when you are on S3 and you have what's the name? What's the name? I don't remember what's the slowest S3 buckets that they can have option, that the servers usually are like in the North Pole, And why are they having that? And they are having like super old servers, like literally they are buying computers that are like from the 90s, as a storage system. And why do they do that? One, to reuse. The second one, because since it's information that you are not requested like with low latency, they don't care. And if they cost less to start running the information, and also in a place where you don't need a cooling system because the environment is already cold, so that's like one of the actually cheap solution that they have, right? That solves the question of my first question, that you can reduce costs and reduce high carbon reduction, like I think. And also you can, one of the things that we are taking advantage of is not taking advantage of the heat, but at least of the environment, like a more instead of using energy to cool down the system, you're using like the natural methods, right?
Yeah, but it's a smart solution, right?
Yeah, actually, that's I think that it's super smart.
Yeah, it's a pretty smart solution.
Yeah,
But
until the moment where the heat it's so much that it starts modifying that very environment, and
Yeah.
then it is not
Yeah.
that cold enough, right? I mean,
yeah,
Yeah, and for sure, the environment near the data center is not the same that like it was before the data center.
no.
Yeah,
And other thing that I was questioning myself about the methodology and the systems is that sometimes I think that, okay, we want nice performance, right? But in one section of the paper, it says that sometimes there are like misbehaviors or sometimes like things that have to be executed twice, mainly because there are errors, right? But I think that because of the high, that you want to achieve low latency and high speeds, you are sending so much information sometimes that sometimes it's faster to slow down. What I mean is like trying to send less, let's say if you try to send 1,000 queries in a second about something, and then of 1,000 queries, probably 300 are going to fail, let's say, you know? And sometimes it's easier if you send only like 600 and all the queries like are going to succeed only because there is like less interruption between trying to handle everything, right? It's like in the microprocessors. When you are adding microprocessors, if you have like one processor, you can use the 100% of the processor. If you have two processors, probably it's 1.7% of each one, right? Well, it's like if you had 1.7. If you have three, it's like actually like 1.9 or 2.1, you know? The more that you add, only in the in the management, you are reducing a lot of performance, right? So that sometimes I question myself if we are trying to do things so fast that actually we are reducing the speed of some things. I don't know if I explained my question correctly.
yeah, I think there is a paradox that it's called Hebron paradox. I don't remember right now the name of the paradox, but it's saying that sometimes when you are thinking that something is going to, when you are thinking that someone is going to be stopped, like just let me look for that because I don't remember right now like exactly what it's saying, but yeah, it's related to that. That sometimes you are thinking that you are like doing something that you don't want to do, and the solution is going to do the opposite of what you are trying to do.
Yeah, and just like last comment, this is like in embedded systems on car and on automotive that happens like for example with airbags. Sometimes if the airbags react too fast, actually it can cause more problems if they are not like in a threshold, right? So they have to act like, for example, if there is an accident, the airbags do not have to appear suddenly. They have to wait as after some microseconds, let's say, so they can be released, because if they are released before, they can cause more issues than helping, right? Just like as a comment. And I think the same concept apply in so many things. Nice. The press products. But well, those are like my questions that I have. I don't know if anybody has like other topics. I have a lot of questions, but are in the other sides of the paper, but I don't want to consume the day.
Okay, thank you. Well, as once Wiseman said, all humanity issues is like energy issues. So yeah, it's unsolved problem, definitely, and we are working through that. So I just saw an email from actually from Hugo, Hugo Armando, the second, who was supposed to present the second part. And he's saying that he has some problems, something happened in the work, and he cannot make it to the class today. So anyway, apparently the second part of the paper is it's not going to be presented, but I don't know, Paul, you want to say something about it, or? I mean, if it's related to the first part, but if not, we can skip.
Yeah.
No, I can continue with my presentation.
I was in charge of the discussion of that part, so he will be rescheduled for that second part, or what?
Yeah, probably. I don't know when, but I just saw the email actually that he's saying.
Yeah.
Because I was seeing that I'm not seeing him here. Then I checked my email and saw I received an email just some minutes ago that he cannot make it.
Okay, that's kind of sad. I had like a dynamic setup.
Oh, yeah.
But it's okay. We can wait. I mean, it's okay. It's better.
But,
if we wait, like,
But I think Paul is the next one.
Yeah, Paul is the
Yes.
Paul
Sorry,
Mejia is the
Paul.
next one.
Yeah, it's like the next paper is like an extension of the first one, right?
It's
mhm.
still about sustainability. Yeah.
Yes.
So maybe Paul, wait, give me 5 minutes, 10 minutes. Okay. So let me talk about what I was supposed to talk. Then we go 5 minutes break. Then we can continue with you. So
Okay.
actually, for those that they were not here 6:20 something, that I was just chatting with other students. By next week, we already going to finish the first presentation. Okay, so everyone going to present once. So the idea for the second part, I was thinking I give you a chance to pick your own paper. So I don't just give you papers, you go read and you come to present. So basically you can pick any paper related to cloud computing, any topic that you are interested to, probably not review paper, not necessarily review paper, it can be technical paper, and come and talk about it. So I don't know if anyone is opposing that idea, if anyone, I don't know, don't like the idea, or they want me to pick their paper. Oops, where is this? So basically for the second part, okay, after this deep dive presentation, I was thinking everyone, I mean, basically you're going to repeat the same structure, okay, with the first part. So one presenter, discussion leader, note taker, but now you can pick your own papers. But in order to pick the paper, I want you to suggest 3 papers that you find interesting to read and present, then allow me to basically approve one of them. Okay, but I just want to make sure the papers are related, the papers are good papers and coming from good resources. Okay. I'm not hearing anything.
yeah, it's okay.
So you agree with that?
For me, it's okay.
So it would be great, for example, the first 3 groups, at least the first 3 person, this one, not this one. So they can suggest it before next week, okay? So I can check them. So when we have a next week class, we already have confirmed paper here, because this is not just for these 3 people that are going to read and present, but for everyone. Is it good? So
Yes,
shall I repeat this this structure here, or you want to go like this? You want to put your own name?
Here.
I think like that is good.
Yeah, I think that it's okay, right?
Which
Let's see
one?
how it works in the first week.
The first one. So I just copy paste this one.
No.
No,
I say the
You want
look
to
at-
keep it like this?
yeah.
Yeah,
So
let's
believe
see
that-
how it works in. Let's see how it works in October the 13th, and well, then we are gonna say to you if we can continue or we get back to the first model.
I mean, anyway, it's just about the paper. So if you don't want to pick a paper, I can pick a paper for you happily. There is no problem with me. If anyone is struggling with picking a paper, I can pick for them without
The
problem.
presenter is the one that selects the paper.
Yeah,
right?
yeah. The presenter is the
Okay.
one selecting and suggesting the paper, so I can approve. So in order to paper, there was a question about what do you think, which type of paper? Of course, you can go to Cloud, Google Scholar, whatever you want to do, okay? Cloud security, for example, these are the keywords I search. If you're coming from Google Scholar, make sure you're picking papers not so old, at least for the second part. I know the first part, there were papers coming from 20 years ago. Okay, but those were mainly review paper, okay? Literature review and survey paper. But from this one, make sure the papers are from last 5 years, last 6-7 years to have basically better understanding of the latest developments, okay, last 5 years, let's say. And make sure the papers are, if they are coming, for example, let's say from 2018, make sure they have good number of citations because it means they are good paper. It's not the only factor, okay? Or another way you can go and search is search through Scopus, which is way better than Google Scholar. Because at least the sources that you have here are sources that are peer-reviewed, okay, not just any type of paper. There are, at least you make sure that you have peer-reviewed paper here. QRT. So here again, you can filter. You say, okay, you want to just last, I don't know, last 5-6 years, okay. You want to say, for example, you want papers from certain country, certain journal if you want, certain university if you want. Let's say you just go with English, limit to.
Why 2023?
There are papers actually get accepted but published in next year. They get approval, but the publication comes next year. That's why.
Yeah, I see what's happening there.
Yeah. So basically, because there are a queue in the publication for the journals, so sometimes you get the approval, the papers get accepted, but it is available online, but the publication date will be marked as like next year. So that happens. So, for example, like this, you can filter, then look for the paper, the topic you want. Of course, you want to make sure you're going slightly better keywords, not just something that gives you a lot of paper. Then good things to pay attention to is number of citation, because the paper, if the paper is cited more, it means it's more valuable in the science community. That there are more people basically researchers are referring to that paper. So it means it has more value, basically. If, for example, there is a paper, no one referred to that paper, it means the paper either just totally ignored, there is something wrong with it, or it's not just interesting topic or idea that no one start building on top of that or refer to it. Yeah, then if you want, you can basically make sure you're filtering. I don't know, you want to just maybe, I don't know, you want to maybe just look for journal papers, not conference paper, okay, or book chapters, or maybe you want to pick certain journals that are better, like more famous journals that comes from IEEE, journals that comes from ACM, okay. Those are, of course, more prestigious journals or journals coming from Elsevier's as a publishers. So basically try to filter a good basically papers, find 3 interesting papers that you know you have access to, okay, and include the links directly to the PDF in here, okay. Because not all of them are accessible, at least with the access that we have. Some of them are open access, so they are definitely, for example, they're all open access. Maybe you can go all open access. Then you can limit to, so anything then you pick, it would be accessible. The PDF would be accessible for sure. But if you find something that is not open access, go to Google Scholar, search the title. Sometimes you find the PDF, something like this. You see the PDF is uploaded in ResearchGate, in academia, or in just university websites, our archive. You can find it and you can put the link here. So pick 3 papers that you find interesting, whatever topic related to cloud computing. So it doesn't, these 3 papers in one day doesn't need to be under the same topic. It can be anything. Okay. So suggest 3 papers, then I check them and I approve one, and then we'll go with that. Any question? No. All good? So, but if anyone was struggling with finding papers, just let me know, drop me an email, then I'll basically suggest a paper. So if there isn't any question, we can go have a short break, come back by 7:50, 8 minutes break, and then we continue.
Okay.
And go ahead and share your screen and start presenting.
Mm-hmm. Now you can see, right?
Yes.
You can see the presentation.
Yes, yes.
Okay, my paper is related to sustainable cloud computing, foundations and future directions. In this paper, this is a paper that explains the current problems and recommendations for the future about sustainable cloud computing. Let's talk. Major cloud computers, major cloud providers such as Microsoft, Google, Facebook, and Amazon, to mention the biggest ones, rely heavily on data centers to support the ever-increasing demand for their computational and application services. But this has a financial and carbon footprint related costs running such large infrastructures in a negative way, and that impacts the sustainability of cloud services. Most of existing efforts, the currently efforts, primarily focus only on minimizing the energy only on the servers. But this paper takes this problem as a holistic like problem, including servers, networks, storage, and cooling systems. This does mean like a whole unit, not only servers. In advance, my paper was a little one, so this will be quick. Only 6 pages. The cloud, the data centers, and the challenge of sustainable energy. The large consumption of electricity of CDCs, let's say CDCs across this presentation for cloud data centers, the community or the whole world is facing the challenge of sustainable energy economy. And you can see in this chart from 2014 that started the cloud computing until nowadays, and the projection to 2030. This chart shows that the prediction to 2030, if we continue this path of growing and also energy consumption, will be 8,000 terawatt hours by 2030. And the major concern is that currently the main energy resource is from carbon, and this is a huge a huge footprint, carbon footprint that impacts negatively the whole world. Also, there are existing energy aware techniques that mainly focus on servers, but this is changing to, and the focus is changing to the whole system, the other components like saving every watt. That's saving every watt is very important for big data centers. 1 or 2 watts, believe me, there's a huge difference in the real world. These are the big players of CDCs, Google, Amazon, Microsoft, and IBM. They are struggling with the current energy scheme, how they power their data centers. But for the future CDCs, those are required to provide cloud services with minimum emissions of carbon footprints and heat release in the form of greenhouse gas emissions. This like saving the planet in a saving the planet scheme. The green energy is the one we know that there is solar and wind, but we're talking about a little more about this in the next slides. This figure shows this is a conceptual model that for this paper for these authors. The figure shows a conceptual model for sustainable cloud computing in the form of layered architecture, which offers holistic management of cloud computing to make cloud services more efficient and sustainable. There are, as you can see, the 4 main components that are the cloud architecture, remote CDC, cooling manager, and power manager. For cloud architecture, this is divided into 3 different subcomponents: software as a service, platform as a service, and infrastructure as a service. Software as a service tell us that this layer is the application manager is deployed to handle incoming user workloads, which can be interactive or batch style, and transferred to workload manager for resource provisioning. The platform as a service, for this layer, the controller or middleware is deployed to control the important aspects of the system. Infrastructure as a service, this layer contains the information about cloud data centers and virtual machines, VMs. The VMs migrations are performed to balance the load of virtualization layer for more efficient execution of workloads. And the other module, the cooling manager, for this module, the thermal alerts will be generated if temperature is higher than the threshold value, and it has heat controller that will make an action to control the temperature if there's a minimal impact of performance of the CDC. When the environment is very warm or heat, the data center started to throttling, and this is bad for the performance of the data center. In the model of power management, well, I need to highlight that this paper only highlight the problems that what are their vision for to take into consideration for the future improvements, but they are not like solving anything. They are just proposing a model, and that's it. And for power management, this control the power generated from the energy resources. They can be renewable or fossil fuels In this case, it's the same. Fossil fuels are the same as the grid electricity, that the one we plug in the from the street. To enable sustainable cloud environment, the renewable energy is more preferred compared to grid energy. But if, for example, there is a deadline for workloads, then grid energy can be used to maintain the reliability of the cloud services, because this is more, well, as a business, from the business perspective, it is more important to have reliability on the services than green energy. For remote CDC, the VMs or virtual machines and workloads can be migrated to remote CDC to balance the load effectively. This is the model that they are proposing for sustainable cloud computing. Also, there are issues related to the energy and reliability, like in the previous presentation, that if you are struggling with energy trying to save too much energy, you will be having reliability issues, throttling or performance or scalability, things like that. That you can imagine that happen in the data center. Sustainable cloud services are attracting more cloud customers and making it more profitable by improving energy utilization. It reduces electricity bills and operational costs to enable sustainable cloud computing. But on the other hand, you need to provide reliable cloud service. And some of the issues is, you can see from energy perspective, is to reduce energy consumption, to reduce underloading and overloading the resources, which improve load balancing. If there's for example, if you have a request and you have an underloading and then you have an overloading request, at the time is important here that you can deploy the services. Also to minimize heat concentration and dissipation in the cloud data center, to reduce carbon footprints, to make environment more eco-friendly, to improve bandwidth and computing capacity, to improve storage management like disk drives, and from the reliability perspective, to identify system failures and their reasons to manage the risk, to reduce the system level agreement violation and the service delay, to protect critical information from security attacks and blah, blah, blah. Also to reduce return of investment, to improve scalability and migration of mechanism of the virtual machines. Their approach is this diagram. This is my final foil that I will be explaining their 7 aspects to take into account: application model, virtualization, waste heat utilization, thermal aware scheduling, and renewable energy and resources and capacity planning. This is the factors that for these authors are the most important to take into account for the future sustainable cloud computing. For application model, we have the data parallel. For data parallel model is a form of parallelization across multiple processors in a parallel computing environment, which focuses on distributing the data across different nodes. For function parallel model, is a form of parallelization of computer across multiple processors in parallel computing environments. You can see my pointer of the mouse, or
Yes.
okay.
Yes.
I will be trying to point them. The message passing is an interface that improves the energy efficiency of the CDCs by it crosses the the functionality between a set of processes which are mapped to nodes or servers in a language independent way. They are pretty similar, but they have their own like specifics for application model. Another aspect is the resource, the yellow one, mustard one, resources targeted in energy management. The main solutions is not take into account the whole devices that consumes energy in the system. For example, that we know that processor is the main actor in this role and in this play. It consumes about 45% of the energy, leading by the cooling system that it consumes about 20%. The other ones that like memory and storage and the network consumes like 15% and 10% respectively. For thermal aware scheduling, the important components of thermal aware are architecture and scheduling mechanisms. The architecture can be single core or multi-core, while scheduling mechanism can be reactive or proactive. Heating problem with during execution of workloads reduces the efficiency of cloud data centers. For virtualization, during the execution of workloads, virtual machines migration is required to balance the load effectively. And I can imagine that you can if you load the balance also geographically, you can have I don't know, you can use the time zones effectively. It's not the same to use a data center located in a heat country in a warm location than, for example, I don't know, Russia in the winter. You can have you can take advantage of the location if you can do an optimized virtual machine migration and load balancing. And also applies applies the same for storage migration. For the capacity planning, cloud service providers must involve an effective and organized capacity planning to attain a solid return on investment. The capacity planning can be done for power infrastructure, the IT resources and workloads. The system level service level agreement should define service quality parameters to ensure backup and recovery, storage, and also availability to improve the user satisfaction and attracts more customers in the future. More customers, that means that you can have more money to improve this kind of approaches. The renewable energy, the green, oh, sorry, maybe this one. The energy resources can be solar or wind. The energy storage device, like real net metering or batteries, and the location, like offsite or onsite, are important components of renewable energy, which can be optimized. Like I said, maybe geographic location can be an advantage in some cases. But it faces the main challenges of unpredictable and also the capital cost of green resources. And we know that using, for example, the electric cars are supposedly better for the environment, but they are way expensive than the common cars, that petrol based cars that we usually use. Also, another thing is the waste heat utilization. In this paper, the authors didn't mention more than heating a using the heat to heat in a building. More than that, but I can. I think that they can be other heat utilization, but for now we are only getting this solution or this approach. For the cooling mechanism and heat transfer model, these two play an important role to reutilize the heat effectively. Do the consumption of large amounts of energy, the data centers can act as a heat generation, a big one, and that's it. I don't know if you have any question. This is a pretty short because, as I said, it's only 6 pages of the article, but this it's like an extension of the previous paper.
Okay, thank you, Paul. Yeah, indeed, it was a short paper. But if I'm not mistaken, the author was the same with the previous paper. If I'm not mistaken, they are both come from Rajkumar Bhuya, which is quite famous actually.
One thing that is not paper related or it's for technical information, but it has too many miswritten words, like too much orthographic. I correctly said in English, orthographic mistakes.
Misspellings?
Misspellings, yeah.
Misspelling.
Miswritten words. Yeah. Because I can imagine that the people that write papers very often, they have like a good writing.
No,
Yeah,
it happens actually.
Yeah.
It happens. So it's supposed to basically be detected during the peer review process, but sometimes just doesn't.
Yeah.
Anyway, let's pass to the basically discussion part. Who is leading the?
Mike Gautier.
Yeah, Gautier.
Well, just to confirm, do you have any questions? I mean, to my classmates, and any other question? If not, well, I can continue with the discussion. And well, in this paper, there is a pretty interesting statement, and it says sustainable cloud services are attracting more cloud customers and making it more profitable. From the point of view of the attracting more customers, I would ask to my classmates if in their company or if in their experience they already know or hear about any cloud service offering, including as a differentiator, it is sustainable. I mean, when a seller goes to your enterprise and they are trying to sell you a cloud service, they are saying this is reliable, this is 24 hours, 7 days a week, blah, blah, blah. And also it's sustainable. The carbon footprint is pretty low. Have it happened to you? Have you heard about that in your enterprise? Move the decision to take an offer with some kind of sustainable offering. It happens.
From my experience, I have never heard someone saying like, let's just go with the most environmental or green solution. It would be interesting to see if, I don't know, organizations like Greenpeace and the like do place important care on where they decide to cite their, to host their website, right? I mean, maybe they can provide us some advice.
Yeah, maybe these guys can have some kind of decision matrix that includes the sustainable item in some kind of a percentage, maybe, don't know, 10%, 15%. But as you guys, I never have heard about an offering including this kind of statement at the time when you get the offering. Maybe the sustainable offering, maybe it's added as a given. Maybe say they have some kind of certificate or something like that. But since my point of view is pretty weird for me, that the paper says that sustainable cloud services are attracting more cloud customers. I guess it's more as a fact that the reliability in fact can attract more customers, but it's weird for me.
I think, Gauter, I think in this about, I mean, it's a really good question, about a valid question, but probably it's more valid for enterprises to choose, for example, Microsoft, Google, you know, like which cloud providers they go with. Amazon, for example, they have certain ESG requirements. Okay, ESG is standing for environmental, social, and corporate governance. So there are certain requirement for certain enterprises that they have to pick, and they have to basically give more weight if there is any company providing sustainable, with low sustainable cloud, as you're saying, with low carbon footprint. But as a person, it's I mean, at least my personal opinion, this part, as a person, really we don't get much I mean, how can I put it? We're not really paying attention as a user. Yeah. I mean, I know there are certain people that are really I mean, how to say, environmental activists. I don't know, they are so worried about everything environment, and they care exactly. They really put this thing, consider this thing in their day-to-day decision making. But majority, I don't think so. Individuals.
Indeed, it's my point. I guess it's more realistic that an offering is more direct to the business point of view, not too much from the environment or sustainable point of view. That was my point, and well, it seems that nobody else, at least in this class,
cares about environment here.
like your question is like why the users are attracted to these kind of cloud services only because they are sustainable? Is that your question?
The request basically, he's saying if the cloud providers claim that they are sustainable, are you giving basically a higher priority to go and use their services, or you don't care?
Maybe yes, because this is generational. I have heard from young people that they prefer, I don't know, to pay a little bit more for a service that offers like a sustainable solution to the problem that they have, instead of wasting uses the service that waste other resources, and like being like green heroes, something like that. I think it's a collective mindset for young generations, that which is good from my point.
Yeah. Maybe in the future maybe in the future it's gonna take more weight. This kind of things in the future. Okay.
Yeah.
Well, I see, sorry to interrupt. What I see is that, for example, I work for Bosch, and they have their own cloud service internal for IoT devices, but most of the their cloud relies on AWS. So if you want to say, hey, we are saving the environment, is it by we are using a different provider? You know, just like that, and it depends on the infrastructure. For example, they said, oh, we have devices that works with batteries. So the batteries are up to 5 or 10 years. So that's how they help the planet. But for me, it's not reliable.
But I think that most of this is at the end of the day, business are business.
Yeah, right.
It doesn't matter if you are saving the world or you are not. And most of the companies are doing this kind of stuff because they have some kind of discount on taxes, or they have like this kind of advantage that they can take because of they are using green energies or this kind of things.
Also,
So,
marketing strategy.
Sorry?
Marketing strategy.
Yeah, so at the end of the day, I think the most important thing about these papers is knowing that there are people that are really caring about this. Because before this presentation, I didn't know that there were actually researchers trying to minimize the impact of the cloud computing in the environment pollution. So I think this is very important, and I think this is good to know that actually there are people that is caring about this.
As you are saying, Pedro, this is a business, and the cost of energy, for example, in Europe, in I don't know, in Spain and Germany, it's increasing a lot. It's higher and higher because of the war, because of the pandemic, and many reasons. And the companies are struggling with that cost of the energy.
And also
Yeah.
they are very sensitive to other factors. For example, here in Mexico we have you pay X amount of money each month in your house, and it usually maintains plain if you don't have more energy consumption. But in other countries, it depends of the season. It depends of other things that increases or decreases the prices. And for example, now in Europe with the war, the energy costs are in the sky right now. So
Yeah.
it's very difficult. It's very difficult for them right now.
Actually, I have a question about this paper. Can you go back to the previous slide?
Yes. This one?
Yeah, that one. It is kind of funny that in this paper, if you see this categorization, they are seen like research issues. But in the previous paper, they are seen like taxonomies. So what do you think that is, or why do you think that this is happening?
No, because there are different approaches, different points of view to abort a problem.
Yeah, but the thing is that here in this paper,
Mm-hmm.
the author is seeing these like issues.
Mm-hmm.
And the other one, the authors are seeing this like a categorization. They are like doing like this split of we can put this and this and we are solving in this way. But in this one is more like oh, these are the issues that we are seeing when we are doing this split.
That I don't know what to say, but I mean, it's a question for the authors probably, because the author is the same. But in the previous paper, they are trying to introduce a taxonomy based on different approaches. Okay, so they are going a slightly more detail. I suggest, okay, comparing to this, what we are just having here. For example, in the previous one, if you check, for example, for application design, you have taxonomy, I mean, different approaches. Here, it's just basically 3 branches, how you can, basically what are the research issues. I don't know, but it's a valid question, but I don't know.
Okay, got it.
Okay, thanks to participate with this first point of view. Let's move on. Well, also in both papers, there is something called well, maybe in the first one, it wasn't said as in the second, but there is a concept, free cooling. This is a way to get cooled the data centers. But what do you think about this? Do any one of you can let us know how it works and also why it's free?
Why
It's
free what?
free. It's free once you get there, right? But you need to get your stuff there first. I mean, because you can go on and take your server and put it like in a mountain of snow somewhere.
Yeah,
right?
you got. Yeah, you have a pretty good point. You said put in a pretty cool place, and it's pretty much how it works. It works based on location. If you are, as Paul said in his explanation, if you are in Russia, the and if you get a threshold of temperature, the free cooling system is going to start to work. If the outside temperature is going up, it's going to stop to work. But when the temperature gets low and it reaches a threshold, this system starts working. In fact, what I understand, if I go to a reference paper, and well, it works like it gets the cooling from the outside, gets inside the building or the data center. It goes through the current climate machine, and after that goes inside the data center. I mean, the outside temperature goes inside the data center, and it's why you can say it's like free. Obviously, you get to pay for some mechanisms, everything, but that's why it says it's free. And also, the pretty important thing at this point is that you must to be in a place, in a location that goes the benefit of this kind of strategy to use the natural resources in order to get this resource as free. And well, well, this is an explanation what I get about this this concept. I was interested because it says free. It's free. But well, do you think it's really free, or there are some costs on this? I said yes. What do you think?
Another question will be, why are not too many data centers in the North Pole, for example? I think there are other costs related.
Human
Also,
resources. Who wants to be living there?
correct. Political also. Yeah, I think it's not that easy, but
Yeah, but for sure there are extra costs involved. But
Yep.
I mean, you were in your presentation, you said I think you mentioned like 40% comes from CPU power, 20% something comes from cooling systems, right? 20% of power consumption. So if they can make that 20% like 1% of the cost, still I mean, you can consider it like it's too smaller than you can consider it free, but of course it's not free. And it's not also reliable. I mean, we can't do that, of course. You remember, I mean, when we had distributed system, we discussed about physical location matters really. You want data as close to you as possible. In certain applications, you really cannot afford that much delay for your data to go all the way to Nord Pool and come back to you. You can't afford for certain applications. And I mean, you may consider, I mean, by the speed of whatever how to say, light, how much it takes, but still that matters. So for certain things, you can't even afford that much delay. So it's not just, oh, let's put everything to the colder place in the earth and then we're good to go. We are reducing a lot of costs, we are reducing footprint, carbon footprint. But no, again, security matters, right? Security of data matters, physical security of data matters. A lot of things comes to play.
Also, going against Greenpeace organization.
But we should get another story about how these guys handle their IT resources, how they choose, how they work with them. Okay, thank you.
I think right now is like a big problem with, it's a challenge related to how to use the natural resources, like how to store and more energy. Right now there is a big fight, for example, in United States, like, oh, let's start using charcoal and gas and more things that pollute the environment, instead of, okay, let's use solar energy, wind energy, maybe energy from the sea. But politicians are against that because they can make money just because of use gas. So I think it's one of the challenges that we currently have. And that's why I think most of the companies said, okay, no problem with this, or we don't worry about the environment until it is a big problem right now. But all of us can see it. For example, hurricanes and tornadoes and everything, we can see it. But I think most of the scientists are working on this, and some companies are trying to get different projects or ideas to the world. They say, hey guys, let's use this and stop using gas and petrol and all the other resources.
I mean, we're going a little bit off topic here, but when it comes to the energy, it's really isn't that straightforward solution that a lot of people think, oh, just let's go with wind, let's go with solar. It's not. That mainly basically they are the carbon footprint exists. They are just putting it in different part of the world. It's not just generated in that country, because for generating basically solar cell, you need to basically burn oil. And at the end, there is no viable solution at the moment, really. And a lot of our problem, actually, personally, I mean, just my personal opinion, it starts in the war. Even we can maybe say indirectly, war of Ukraine is started because of all this, based on my opinion, nonsense green movements. I mean, my humble opinion, okay? Because sometimes we just don't consider the complexity of the problem, the complexity of geopolitical problems. Just go, oh, let's shut down all the nuclear plants. Let's go with gas. I mean, it doesn't work. It just simply we cannot sustain on that. But anyway, we're going off topic. Let's go back to Gautier for managing this.
Thank you.
Keeping us on track.
Thank you, Madi, for your opinion. Okay, let's continue with the next or the following question, and it is related also to another term or concept that also was mentioned in the first paper, and it is waste heat recovery. In this for this term, I understand that in some way the heat that is getting from the servers, it's used in some way to get cool the data center. What do you think about this? Do any one of you have any detail or opinion about this term, the waste heat recovery?
This is basically the same thing we were trying to discuss in the last presentation, that Pedro Cortes was saying. It was interesting for him finding out there is effort to try to, if I remember correctly, there is effort trying to recover that or reuse that. I don't know anything about it, honestly. I put certain links here. I just browse through them. Apparently, there are in some countries, they are trying to use it for heating or conserving and later using it. But that's all I know. I don't know anyone else.
But this is a pretty good solution because we live in a hot country, but in other countries that are not Europe or United States, Canada, they pay for heating their houses or their buildings, and having this like free heating system from coming from the clouds. So sorry, from the hardware, maybe will be a good fit because I can think that heating a room by, I don't know, resistance or something like that. It's not cheap to convert electrical energy to to heat, and by doing this utilization can save a lot of energy and also of money. Maybe that's why they are not thinking in another uses, because this is the best fit for them. I don't know. I am just betting here.
Microsoft has a project in which they are putting servers in containers and put it in the ocean, in the cold waters, to water cooling the servers. And I think they are going in the step 2 phase of this project, and it worked. The only problem is that the environmental cost of doing this in mass. So you are heating the water more than in the natural process of the oceans. You are modifying the ecosystem. So there is another solution and also another environment problem.
Was just reading about this paper. Is not computer related, but basically they use like the waste heat to preheat all the plants that melt metal. So I don't know, maybe there will be some place in which you can place servers need to places where metal or iron, whatever is melt, and then you can just start preheating whatever you use.
Yeah, but you can imagine that the Microsoft will be moving their data centers to these kind of companies.
Maybe they are, but they won't be telling you. That's the trick, you know.
as Maddie said, that there are another like considerations for example, security, things like that.
Yeah, I mean, of course. I mean, we can't have that flying around near our precious terabytes of memory, right?
Yeah.
Yeah, you're right. I mean, let's just keep dreaming. Just keep it close.
Let's just waste it, not reuse it.
Now your service is helping to build houses.
I don't know.
Something like that.
Yeah, I mean, something you can always sell it. I mean, as long as things are well isolated, I mean, you can have like whole entire warm ecosystems near data centers. Like, I don't know, come live here. We'll just add sand and you have a beach or whatever.
Yeah.
Maybe another approach for the companies could be improve the adoption of new architectures for microprocessors like ARM, because it's more efficient. And I think Amazon is the only one that offers VMs with ARM processors, and the adoption is expensive, but could improve the energy efficiency of the servers in general.
Yeah, but that impacts the business directly, the costs.
Yeah, but many companies are taking the risk of getting rid of the old technologies and put all the eggs in the basket of the ARM.
I wouldn't say all technologies. It's more like specific design for a specific product, and that's why, like the Apple, like Apple is doing with their computers. They design their own chips for the computers, and they are pretty well optimized. And for example, AMD, Intel, and all the other manufacturers are building one product for too many companies, and that doesn't fit into this kind of model that for specific.
Yeah, of course. You need to also to modify all the software used in the servers to function, but it could be an improvement in over time.
Yeah, I mean, and that's a good point. I mean, I was just reading about it, about ARM, but there's a lot of literature about how they are way more power efficient. I mean, at the end, as you were saying, if we go like everybody goes ARM right away, let's just drop Intel and forget that it ever existed, we will still have problems, right? Because many of our stacks would need to be virtualized or emulated to work over that stack, like our Macs do. And then at the end, it would end up like just hitting the same. But yeah, I mean, it's interesting.
And at the end, it also depends on the money. I am aware that Intel is, this is a secret, Intel is doing like a custom CPU for Facebook that for storage, it doesn't need to process too many information, only to moving the data from one point to another into storage, and they are pretty low frequencies, pretty low compared to the regular ones, and these CPUs don't consume the energy like I will say a number less than 50% of the regular CPU. So maybe this could be a future approach for different segments in the market when we take seriously the environment.
Yeah, change the hardware and optimize the software, and not use focusing on the heating cooling, so in the cooling process. So you need to also improve the hardware and the software to be more and more efficient.
Yeah, exactly. In both papers, the authors are talking about different approaches in order to make it more sustainable. Reusing the heat, just one of them, and probably the least significant way or least important way, but exactly what you were saying, David. Other approaches to make it more energy efficient, basically. Okay. Go ahead.
Thank you. Just to close this discussion, I would say that I learned about virtual machines about 4 years ago. And well, when I learned about that, I thought that these virtual machines were solving many issues about reliability, and also I forgot this word. I forgot improvement and efficiency. But after read these papers, I realized that there are still many issues to solve about reliability and the usage of these equipments and everything.
Thank you so much, Paul, out here for interesting discussion. So before we finish this session, apparently there are some students, they have confusion about the deliverable, about the course, online courses, how to take the online course, how to verify that you took the online course, how to verify that you have certain hours. If there is any doubt like that, you can just voice out, say, and can discuss. Basically, the idea is, I know there's some of the course, you might say, okay, I said 30 hours course, you might say, okay, the video is 5 hours, 6 hours, but then there is exercise that it can take like 10 hours to just do the exercise. Then, so And then at the end, there are some courses, online courses that you cannot keep track because there is no certificate at the end. It's just doing it. But as we mentioned at the first class, at the end, the idea is to verify the easiest way. I mean, for example, if there is a certificate issued by the course, I just check the certificate. If there's a, basically I can sign, I mean, you can sign into your account, show me that, oh, I did these courses. And it's not really, there isn't any hard, basically, process there. Okay, we're just finding a way to verify that based on the course you're taking. And if there is complication like that, you will say, okay, the course is 6 hours, the video is 6 hours, there's 10 hours just to do the exercises, because exercises also will take time. And then that is also okay. We can, when we are verifying that activities, we can meet, talk, and discuss. And basically, you can convince me that that practice was enough. Okay. So there isn't any really solid procedure to verify that. So basically, at the end, it's, I mean, it's trust based. I mean, I trust you do that, and because it's for you, for yourself, you know, at the end. So I don't know if there is any question or doubt. No? If not,
okay.
So yeah, we can end the session. Take care, everyone. Stay safe.